this is tutorial, but I'm sorry, it's not a substitute for reading the RFC documents. There's no real way of getting around that. But what I do hope this tutorial does is it shows you how to navigate through all these documents. Okay? The target audience is you have a knowledge of internet routing, familiar with a database, and here it is RADB, who is database, or something similar. But I'm assuming that you are novices and know nothing at the moment about the Internet Routing Registry. Now, what I was asked to do was this. They said, well, that's a good sound effect. Can you do that again? That's a bit of reverb in there. I was told to aim this tutorial at novices. And I asked, what's a novice? What's the difference between a novice and a beginner? And they said, well, a novice knows nothing and doesn't know where to start looking to find information. A beginner knows nothing but knows where to start looking. Okay? So I hope by the end of this you'll be beginners. At least those of you who are novices now will become beginners. Some useful documents. This is the proposed standard routing policy specification language, RFC 2622. It tells you everything you needed to know or wanted to know about routing policy specification language. But I would actually recommend that you first read this one, RFC 2650. It's called Using RPSL in Practice. It's quite a short document. You'll get through it maybe in about half hour or less. But it sort of creates a context for this document. This document is very much the reference. This document tells you everything, but I recommend read this first. Another document is Routing Policy System Security, RFC 2725. What that's really saying is, if you are going to publish policy anywhere, how do you know if you can trust the data? And this document addresses that issue, a way of authenticating information in the Internet Routing Registry. It's a mechanism for delegating objects and routed top-down delegation for an authentication model for AS numbers, IP address ranges, and route objects. Now, you want to talk to your local database or ADB or whatever. Some of them implement this, some of them don't. I will talk about this for the sake of completeness. Further to do with this routing policy system security is PGP authentication for route database updates. I'm not going to talk about route database, but there is a good description of PGP authentication for things like RADB and other databases in this document, RFC 2726. But I'm not going to talk about the route database, but a lot of the ideas referred to in other RFCs were developed in this one. And the last one to talk about is routing policy system replication. It's a way of distributing data from one database to another. It's a push mechanism. I'm not really going to talk about this at all. This is really more for the registries and what they do. I should say that routing policy system security depends a lot on that RFC. Now, what am I going to talk about in this tutorial? Well, first of all, I'm going to talk about the Internet Routing Registry. Then I'm going to talk about routing policy specification language. That takes up most of this tutorial. Lastly, I'm going to talk about the RA toolset, which is now being renamed the IRR toolset, and a tool in there called RT-config. What I hope to show you is why do all of this? What's the payoff? What's the payback? What's the return on all the investment and time and effort you put into learning this? Here is one. Really, you're talking about generating router configuration files easily and quickly. So, I use a lot of signposts in my tutorial. At least I feel I have a right to know where I am in the presentation and where the presentation is going, particularly as I'm the one giving it. So the contents are, for this Internet Routing Registry, look at the background, structure, why use it, and then a little bit about BGP configuration from the Internet Routing Registry. Well, the Internet Routing Registry was established in 1995, and URL, this one here, www.irr.net, and the idea is to promote stability and consistency of routing. The idea is that network operators share information. Okay? What you find is that the various public databases like the RADB, RIPE and others will exchange data in this routing registry. In this Internet Routing Registry you have both public and private databases. Now what I mean by that is the public databases like RADB, and the private ones would be for the very big ISPs, often run their own databases. The only people who have objects in there are the customers of those ISPs, but these, as it were, databases are also in the Internet Routing Registry. Now these databases are independent, but some exchange data. The RADB in particular mirrors many of the other databases. However, and this is very important, only register your data in one database. Okay? Only register your data in one database. RPSL is a common format allowing different databases to share information and to allow mirroring of different databases. This is a diagram of the Internet Routing Registry. There are at least 50 databases in the Internet Routing Registry. You'll find sometimes that these are not called databases, they're called repositories. This is where you will find an up-to-date list. There are many more. I've only shown 5. There are many, many more. Now, the whole idea is that policy and contact information is shared so that mistakes can be avoided. If you share policy information, you can avoid mistakes. If you share contact information, then if something breaks, you know who to talk to about it, how to get it fixed. Also, at that URL, you'll find information on mirroring, how you can, as it were, mirror one of these databases like the RADB and have your own local copy, if you want to. Now, how do you find information in the Internet Routing Registry? This slide is not in what you might see on the web. You use a WHOIS client, and you point your WHOIS client at an IRR member database. You remember I showed you there were 50 of them. So you would point your WHOIS client, WHOIS -H for the host, for example, whois.radb.net. You have options, and then a query. The WHOIS client is either one written by, say, RADB or from somewhere else like RIPE. But you use a WHOIS client. Or you can mirror a database locally and then point your WHOIS client at your local mirror. To do that, you need to find the mirror port on the WHOIS server of the repository like RADB or whatever. So you can, as it were, have a real-time, near real-time mirror, something like that. So you download every day, every hour, every 15 minutes the information, make updates, and you point your WHOIS client at that. How do you manage objects in the Internet Routing Registry? Currently, there is an email interface. Usually, you send a simple text, ASCII text file to some kind of database robot, and that processes the record, or as they call it, an object. Now, as far as I know, the RADB is working on a web-based interface. I don't know if there are any RADB people in the room. And other databases are also working on a web-based interface. But the idea is there is a database robot, and you send the record, the object, to this robot. There are authentication mechanisms, which we'll talk about, and some of the objects' records have a hierarchical structure, which means unless you have created the top level object, you cannot create anything else underneath. I'll say more about that later. If you want to run your own server, usually you can pick up at least the public software like IRRD or RIPEWS database server or whatever. This is the one I think written by Merit. Okay, why use the Internet Routing Registry? Well, when you're peering, probably what you have to do is register your routes, filter your peers. Some of the big transit providers and big ISPs ask for this. They filter everything that they don't recognize. And it's useful for fixing problems with some contact information there. So if anything on your side breaks, you're not the last to hear about it. Somebody can tell you or tell the right people in your organization what's gone wrong and what should be fixed. So there are some good reasons to do this. If you are looking for others, I suggest on the IRR web page there is a FAQ, and there is a discussion there, I think, from the NANOG mailing list about good reasons to use the Internet Routing Registry, as far as I remember. Okay. And as I say here, some of the big ISPs and transit providers will only advertise customer routes once they see objects in the Internet Routing Registry. So here is an example of a database in the Internet Routing Registry. There are at least 50 plus databases in the Internet Routing Registry. At last count, there were 40 available at whois.radb.net. They are mirrored, so in other words, you connect to one server, whois.radb.net, and if you use the correct flag or option to your Whois client, you can look at the data in, say, 40 of these databases. This is a URL to find out the up-to-date list of databases available at whois.radb.net. And these are the primary ones, RADB, ANS, and what I mean by that is normally at something like RADB, if you can create or change or delete objects in that database, and others are only copies. So the other ones you can't change, but there are some that you can. The ones that belong to RADB database you can, the other ones are simply copies. The Whois server is whois.radb.net. Information is at this www.worldwidewonder.radb.net. I would encourage you to read the information first and then contact the help desk if you still have questions. Okay? So I'd encourage you to read all the information first before you talk to the help desk. Creations, updates, and deletions of objects, that's records in the database, go to auto-dbm@radb.net. This is where you send this simple text file of the record for the database. However, this is a robot, so don't send any questions to this. Okay? Just very fast, some of you might have heard of RIPE database. There are 5 databases available at whois.ripe.net. This is the server. RIPE is the primary database. It does information on routes, routing policy, also on IP address ranges and reverse delegations, and IPv6 allocations and assignments. So it's a slightly different, as it were, database. There's rather more in it. It's not only routing policy, but it's also IP address allocations and assignments and reverse delegations. And there's the Whois server, whois.ripe.net. If you're looking for information, it's at this URL. Okay, well, why use it? Well, you have all kinds of strange things happen every day. I mean, the internet is not supposed to break. In an ideal world, it wouldn't break, but you get all kinds of BGP routes injected into RIP, back into BGP. Somebody leaks 128/7. You get these bogon leaks, 10/8 leaks. And daily, somebody is leaking someone else's prefix. Okay? So the idea here is there are some good reasons why you should say publicly, this is what I am doing. And also for you to know what is the other guy supposed to be doing. And then you can compare with what the other guy is supposed to be doing with what you are seeing. Okay? Another example, good reason is this, you can do BGP configuration from the Internet Routing Registry. This routing policy specification language allows abstract of high-level policies and policies for each autonomous system. Now what we're saying is here is this is something that is human readable but is also machine readable. When we look at this tool set later, we'll see that you can take these, well, maybe not human readable, geek readable objects, might be more accurate to describe it. That does not imply that a geek is not human, although some people argue about that, but that's for later. So the idea is you can put in your high-level policies here, yet you can also configure your routers from them. The Internet Routing Registry is routing policies, routes, and contact information, and it benefits from the data and delegation of others. And just on that point about the IRO tool set, there is this tool, RTConfig, and with that you can generate router configuration files, and the idea is to automate details and tedious aspects of generating router configuration files. The whole idea is you put your objects in this routing registry, and then you point this tool towards the routing registry. It will generate your router configuration file. And guess what? You get to go home on time in the evening from work. Well, sometimes maybe. Okay, that's the first part. We've looked at the Internet Routing Registry. We've said why there's some good ideas of sharing this information, policy information and contact information. We've said it's a good idea to share policy information so that everybody knows what we're all supposed to be doing, and then we can compare with what we actually see. How do we do this? How do we share this information? What's the format of this information? Well, it's the routing policy specification language. Now, throughout this presentation, you'll see a milestone. This is a sort of a signpost that tells me where I am. So I've just done the background. I'm now going to take a look at RPSL objects. This is for most of the afternoon. This bit takes quite a lot of time, specifying policy. And then routing policy, system security, and then some advanced features if we have time. So, let's look at the background. What is this routing policy specification language? And I'm just stop for a second and say, any questions about the first part? Well, either everybody understood everything or nobody understood anything. Okay, fair enough. Let's look at routing policy specification language. It's an object-based language, and what I mean by that is it's based on records. We're not talking about object-oriented programming, we're talking about records. And the records are records for routes, autonomous systems, router, contact, and set objects. This language defines the syntax, semantics, and format of data in the Internet Routing Registry. It is vendor independent, okay? And it is extensible. It is a proposed standard, RFC 2622. It's based on RFC 1786. Now that is based on the right document 181. But this was written in October 1994. It was republished then as an RFC, and it became the de facto standard. Now currently there is no support in RPSL for IPv version 6. However, don't despair. We've created RPSL NG, RPSL Next Generation. What's that about? This is building in support in RPSL for IPv6 and multicast routing policies. There is a mailing list, rpslng@ripe.net. A draft document was published towards the end of April of this year. It was published on this mailing list. Now, the IETF working group will not be reopened. It's just when this draft is ready, it will go to the IETF list. So if you're interested in knowing more, look at this mailing list. So, back again to routing policy specification language. It was based on RFC 1786. It was the original common format for data in this Internet Routing Registry. However, it had some weaknesses. Some policies cannot be specified in this format. The Internet Routing Registry people decided if this is going to be useful, we need a much more powerful language capable of expressing the policies that people actually use. So this, I'm afraid, is a little bit of a history lesson. RPSL was designed to be more expressive than RFC 1786. Policies were to be expressed at the autonomous system level.
Where were they expressed before that? Sorry. Before they were expressed at the AS level, where were they expressed?
I don't think they were expressed at all in some cases, or not particularly well. I think that RFC 1786, RIPE 181, it was an attempt to express routing policies, but it didn't go far enough. At least, this was based on RIPE 181, and there in RIPE they were sort of doing not only AS registration but also policy registration at the same time. In the Ireland region, they had separated AS registration from policy publication. And I think they started off with the policy routing database, which I think is around 1991. Then you had what they call RIPE 81, which is 1993, RIPE 181, which became RFC 1786, 1994, and then RPSL, which is 1999. Okay? Does that answer your question? Okay. So they were, as it were, thinking about this. And the trouble was, they did have autonomous system objects in RFC 1786. However, there were some things that were a little bit ambiguous, and in other places it didn't go far enough. That was the problem. And you couldn't build router configurations from it. So they decided to allow more detailed policies in RPSL, and that you could build router configurations. Okay, that was the history lesson. Back to a milestone. If this is highlighted in green, that means it's been completed. Red is the next subject, RPSL objects. This is what we've yet to go through this afternoon. And now RPSL objects. Any questions on the background in RPSL? Okay, just had one. Objects in RPSL. As I say, RPSL is based on objects, but we don't mean like object-oriented programming, we really mean records. The format of RPSL is very similar to what went before, RFC 1786. Very, very similar. You have objects and attributes. Now, coming from my sort of database background, that before I called that records and fields. But the routing registry people talk about objects and attributes. The attributes have values, and each attribute can take a different type of attribute value type. I'm going to talk about object names and reserve names. there are some restrictions in RPSL in what you can call the objects. I should also say that there is more than one implementation of RPSL out there, and you will find slight differences between them. So you should talk to, or at least read the documentation of the database in which you have your objects. There are slight differences between what's in the RFC 2622 and what you will actually see. I will try and flag one or two of these differences, but I would encourage you to talk to the database administrator or help desk or read the documentation of the database in which your objects are. Now, he said RPSL is based on objects, and each object or record describes an entity in the real world. There are different types of objects. They call them object classes. Some people, you might see written RPSL is based on classes. What they mean is different classes of object, different types of object. There are 12 types of object, and RPSL defines one more, the AS block. That's this routing policy system security. I'll talk about that later. I just say that the key cert object, which is used for authentication, is not in the RPSL RFC itself, but it is in that other one, RFC 2726. So the RFC RPSL makes a hidden or implicit reference to this key certificate object, but in RPSL itself, in those RFCs, it's not defined. I'll say a bit more about that later. But basically, RPSL is based on objects. Here is an RPSL object. It's a person object, and you have, as it were, attributes and values. You have your attribute name here, terminated with a colon, then some blank space, and then the attribute value. You have a comment beginning with this pound sign, hash sign, whatever. You have line continuation. You can continue the value of an attribute onto another line. This is a fake object, a test object, one I just made up for the sake of example. And you should see, if you've used the RFC 1786 objects before, that this object looks very, very similar to what went before. That is both a strength and a weakness. Some people say, oh, I know all about this stuff, I don't need to know any more, so they don't read the documentation. Other people say, cool, I've seen some of this stuff before, I think I can work my way through it, and you can. So RPSL objects, similar to what was before, it's basically an object is a set of attributes. The attributes can be mandatory or optional. The values are either a single value, a list value, or a multiple value. This is an interesting one. Sometimes you can have more than one value for an attribute, or you can just have a list, a comma-separated list. Okay? So sometimes you get an attribute that it only appears once, but it takes a list of values after it. And a multiple value is where an attribute can appear multiple times. So an example is the TEC, technical contact, can be multiple valued. Okay? But a member's attribute can take a list of values. I hope that will be a little bit clearer later, but it is important that you know the distinction between single, list, and multiple. And I recommend you always look at the object template. Now, what you should do in your local database, you usually do something like who is -t lowercase t option, and you'll get a list of all the attributes in the object. I think that's true for RADB as well, who is -t. But check the documentation of the database in which you're putting objects. Here's an example. This is the template of a person object. As it were, you have the person attribute is mandatory. It only occurs once. Okay, so the name of the person only occurs once in the person object. Phone number is mandatory, can appear multiple times. Email is optional, can appear multiple times. Now we have another type of object called a role object. A role object, as it were, refers to something like a network operations center or a help desk. A person object obviously just refers to a person. I always find it interesting that in the person object the phone number is mandatory, but the email is optional. And in the role object it's the other way around. The email is mandatory and the phone number is optional. But what I hope you see here is that here you have the attributes. This tells you whether the attribute is optional or mandatory. And this tells you how does it occur multiple times or just once. And again, there are slight differences in the implementations. Okay? There are slight differences in the implementations. For example, some allow description attribute to appear more than once. Other implementations say description attribute only appears once. I should say also there is no admin C and tech C in the person object. I think strictly reading the RFC, you should have an admin C and a tech C in a person object. I'm not sure why you would have an admin C in your own person object, but, well, sir. RPSL objects, there is a class key, which is a set of attributes that uniquely identify each object. Okay? The class key, sometimes called the primary key, it uniquely identifies the object. It can be one or more attributes. It's usually only one attribute that uniquely identifies the object, but you can have more. And it's usually one attribute has the same name as the object's class. This class key must be specified first. This class key must be specified first. So to give you an example, this is a template of the person object. The NIC handle is the class key. Okay, this is a bad example. It's also a good example. It's a bad example because this is the NIC handle, but you see in the person object, the first attribute is person, but this is not the class key. This is what uniquely identifies the object, NIC handle, but person is the first attribute. Normally in all the others, the attribute that uniquely identifies the object is first. In the person object, it's different. The person object has the person attribute first, but this person attribute does not uniquely identify the object. Yes?
Okay, stupid question.
No.
Uniquely identifies the object. You mean this is the only object in the entire database that has that line in it?
It's the only object that has this NIC handle. What I mean is that you could have two person objects with the same name, but they must have different NIC handles. Okay?
Can other objects have a NIC handle in them?
This is a mandatory attribute. It must be there, but no two NIC handles are the same. Okay? What I mean is the way the database resolves two person objects is it looks at this. It doesn't look at this, it looks at this. Yeah?
The NIC handle field is mandatory in an object where it is part of the primary key. But the NIC handle could appear in an object where it was not part of the primary key.
It would be
in that case, it would be data of that record that would not necessarily be mandatory. But for objects where it's part of the primary key, the reason it's got to be there is because it's part of the primary key, not because it's a NIC handle, but because it's part of the key.
Yes. What I'm trying to say is that this can be a foreign key in another object. This can be the value of an admin C or a tech C. It's a bad example to take, but I wanted to do this just to show people that in the person object, this is the class key, but this is what uniquely identifies the object. The class key always comes first. Yeah?
But in the example you're showing us on the screen, you have the class key 5 lines buried in the object.
Yeah.
Are you saying that in a real object, the class key would have to be specified as the first attribute in the set?
Yes.
But where the class key is constructed from a set of objects, only one of those can be first.
Yes.
You're saying that all of the set must be the first,
Yeah.
second, third things in
Yeah.
the object.
Yeah.
So I guess implicit in that is the fact that in an object, attributes must come in a particular order. You cannot switch around order.
In RPSL, the attributes can be at any value and any order, except the class key must come first.
Exceptions and
Exactly. This is the buried bomb in the middle of all of this. Okay? And this is why I want to...
cannot come first in this case?
The person object the person attribute must come first, but this is the primary key. Normally the class key and the primary key, the key that uniquely identify the object, are the same.
But it can also come second or third.
You can put this
It's not after first and foremost.
You can put this nick handle anywhere, but person must be first. Yeah? The person object is a strange one. Normally you have person object and person attribute comes first. Role object, role attribute comes first. Opnum object, opnum attribute comes first. Okay? In the opnum, in the route object, the address prefix comes first. Okay, that's another bad example. I need a moment to explain that. But the thing here is this is not the class key, but it uniquely identifies the object. You don't call it the nick handle object, you call it the person object. But this uniquely identifies the object. This identifies the type of object.
Also, the primary key is not necessarily a class key.
Yes. There's a date, but this not often it is, but in this example it isn't.
It's not. Okay, so the primary key is not necessarily the class key. The class key must come first.
Yes.
Keys are defined as potentially set, one or set.
Yeah.
Is the set an ordered set?
Only to the extent that the class key comes first. All the other attributes can come in any order.
So, if you have a key which is a set, and if part of the key is the class key, then it must of course be first.
Yeah.
All the other components of the key could be in any order.
Yeah.
It's just that they form a unique tuple, and the
Yeah.
unique tuple is the identifier of this record.
Yeah.
That is way confusing.
That's why I decided to talk about this now when everybody is awake, as it were. This is the one, I'm saying when you read the draft and look at it, see what's in practice, you'll see slight differences, but this uniquely identifies the object, but it's not the class key. Okay? It's not the class key. This is what you call the primary key in database terminology, but in RPSL, the person attribute is the class key, and that comes first. No? Not happy?
No, I'm happy.
What I want to do is to encourage you to see, you're reading the specification, you're thinking, this looks okay, then away you're away, well, what's going on here? This is a strange one, as I say, person is the class key. The person attribute is the class key of the person object. It comes first. But it does not uniquely identify this object. This attribute, the nick handle, uniquely identifies the object. But in other objects, the class key is the unique identifier, but not in the person object. You see, if we took people out of the internet, it would all be so easy. Okay? We just had routers talking to each other and the people could do whatever they particularly wanted to do. But it's not called the nick handle object. Does that make any sense?
Yeah.
That's why I wanted to sort of warn you. This is where it gets interesting. This is the one we want to watch. The same is true for the role object. You could have a role called help desk or network operations center, but the role is, that's the class key is role, but the unique identifier is the nick handle. Okay? Any further questions on that? Because it's important you see this early on. Yes?
How do you specify the primary key in the template?
Well, normally the primary key and the class key are the same and they come first. In the person and role object, the class key comes first and the primary key can be anywhere.
Can you go back one slide? Right, in that one, you have the square bracket class key against the class key.
Okay.
But there's one primary.
Yeah, that should be up here as class key, and this is the unique identifier.
Okay, so it's.
That's my mistake. This should be up here.
And should there be a primary key label?
Well, this is the primary key, but this is the class key. It is an inconsistency. This is the primary key in database terminology. My mistake. This uniquely identifies the object, but the class key is the person object, and that comes first.
It's useful to say at this point, one error that often happens on the registry side when we receive these is that people have not removed the words mandatory or optional in filling in the record.
You don't say.
So, when you're showing this, you're showing something like a backus noun form notation,
Yes.
but it actually isn't, and it's important that people know that everything after the colon should be removed from the template, and what you put in is the value of that data record, because otherwise you will have email square bracket optional, your mail address, or notify square brackets optional, where people are saying,
Nobody is that stupid.
I'm afraid. I'm afraid.
Okay, I thought this was a template, and you strip out all this stuff and replace it with your own stuff.
Some people leave the first column of that thing and only replace the last word.
Okay. I am shocked. I am surprised. My view of the world is, this is the attribute, and it's terminated with a colon. Everything that comes after this is the value of an attribute. This is a template. As you fill this out, you throw away everything that's in square brackets and put in your data. I should have an example. This is how you would fill it out. You'd throw away all that's in square brackets and replace it with this data. And as was being pointed out, this is the unique key, the primary key, this is the class key. As I say, person object is a strange one. Okay, any further questions on that? Okay. In RPSL objects, line continuation is possible. And you show this by, at the beginning of a line, you have a space, a tab, or a plus symbol. Comments begin with this symbol, pound sign, hash sign, whatever you call it, and can be anywhere inside an object, but cannot start at the beginning of a line, at column 0. Okay? The only thing that can start at the beginning of a line is either these or the name of an attribute. But you can't put this at the beginning of a line. Okay? An object ends at a blank line, 2 new line characters. And the order of attribute value pairs is significant. What it means is you can send in, as it were, scrambled objects, but the class key must be first. Now, it depends on the implementation, but usually what you find is the order in which you send in the attributes is preserved in the database. Okay? I have an example in a few slides. I'll just skip to, this is one where you have the nick handle here. Here is the class key first, person. Here is the primary key, nick handle here. And in the template, source is written at the very end as the last attribute, but I've put it here. Okay? So strictly speaking in RPSL, the order of the attribute is preserved. If you want to scramble up your object and do it like this, you can. This causes fun for other people who are parsing your object. In the old times, as were before this, the objects followed a specified order, and it was very easy to parse them. RPSL says the order in which the user sends in the data must be preserved. So you might have to change scripts or whatever. This is a comment here, beginning with a plus sign, and this is another comment here, beginning with a blank space character.
Continuation.
Thank you. Continuation.
Can you have
Yes.
the first instance of an attribute have a value of a stationary tab or a plus, or is that potentially causing it problems because it's not sure if it's a continuation?
I think that it must begin here. You can't have the comments, the continuation. The column 0 is very significant. It's the beginning of an attribute.
You've got attribute phone column, and then your image value component in the first part of the valuing attribute phone's got plus there.
Yeah.
So that's all right.
Yeah. This is where the problems are. It's column 0. Okay? Column 0 is the tricky part. Attributes begin at column 0. Continuation begins at column 0. Comments cannot begin at column 0. Yeah? I think I was just looking. The order of attribute value pairs is significant. RPSL objects. Some attributes are now mandatory. In the previous version, RFC 1786, they were not. Some attributes were not mandatory. Now they are. Maintained by is mandatory in all objects. When you read the specification, this maintained by attribute, which just, as the word describes, authentication, is now mandatory in all objects, but some databases have exceptions. For example, in some databases, the person object need not have maintained by. I encourage you to check for implementation details. Okay? Another one is empty attributes. I'll give you an example of that. If I just go back to this template, supposing you decide, I don't want remarks. It's optional. I don't want remarks. Well, some people would just send in that, remarks, colon, followed by nothing. You must check the implementation of the database you're using, because some databases, some software remove empty attributes. Okay? Because they see it as a security risk and they want to preserve the data as the user sent it in. Okay? So you want to check your implementation details when you're reading the RFCs and when you're talking, as we're reading the documentation on RADB or whatever, see what they do to empty attributes.
Maybe that's pretty much it's formally specified in the second what was compliant or not compliant. These ones are answers a lot harder.
Well, some people have already exchanged emails on would that be a good idea to do, but for this presentation, I'm just flagging that.
Understood that this is reality and we have to live with it. It seems to me this is something that should be addressed.
Yes. I'm not going to, it's going to take a bit longer, or if maybe not everybody understands quite what's going on, well, we might put it to later. One thing, I did just check my memory. I apologize, I'm a little bit jet lagged. My body is in one part of the world, my mind is, well, about 5,500 kilometers somewhere else, but 3,500 miles somewhere else. But if you check the RFC, the NIC handle is shown as the class key for the person object, but it's called, sorry? I'm not saying the RFC is wrong. All I'm trying to draw your attention to is...
It's the one exception to a really nice rule.
Exactly, yes. I'm just saying, when you read the RFC, just bear in mind what's actually out there, all right? Just bear in mind there are slight differences. There are not many. You can work around them. You can live with them. But just keep your eyes open when you read the RFC. On the other hand, I could avoid mentioning any of this stuff and just sail through the tutorial and nobody need notice anything until later. Okay, this is a RPSL object again. And I just discussed this earlier. This is the primary key. This is the class key. It comes first person. And you see, one of the advantages of this line continuation is it should make the object easier to read. Okay, it should, as it were, you can put this in for readability. And I would encourage you to do that, just to make your objects a little bit easier to read. Attributes. Well, they are case-insensitive, ASCII characters. The value of an attribute has a type. It can be an object name, it can be an AS number, can be an IPv4 address, it can be an address prefix. All these are defined in the RFC. A complete list of attributes and types is in RFC 2622, but check your routing registry, I mean the database, for any additions. There's one database, I'm not mentioning any names, which has put in a whole lot of stuff of its own. Okay? And it's ripe for argument, but I didn't...
We put something that's right down, so...
Okay, well, we can talk about this, but just saying the complete list of attributes is in the RFC, but some implementations have extra for historical reasons. So let's start at the very beginning. How do you name an object? Object names can have dash or hyphen or underscore inside them. This is one, right, dash dbm dash mnt. You can have digits. They can be case insensitive. However, the first character must be alphabetic, and the last character must be a letter or a digit. Okay? So your object name can have digits, but not in the first character. I'm told off the record the reason for that is that they don't want, for example, people just putting IP address ranges as person names or as names of maintainers or whatever. It's to encourage people to write a meaningful name for the object rather than just putting in the IP address. But that's just off the record. However, with these object names, you have reserved names and reserved prefixes. So just to go back for 1 second, what I'm saying is in attributes, you have an attribute has a type. I'm now talking about the value called object name. Okay? Value of an attribute has a type. I'm now looking at the object name value. And the object name follows these rules, and they have reserved names and reserved prefixes in these names. These are the reserved names. I'm not going to read them all out, but you cannot, as it were, name a person, object, or a maintainer except or networks. Now, if you read the RFC, what it's saying is you cannot use these words as names for objects within certain contexts. You can use them in other contexts. What I do is I don't use these at all in object names. Okay? A very careful reading of the RFC says you cannot use these in certain contexts, but you could use them in others. I recommend just don't use them. Just leave it at that. There are also prefixes that cannot be used as names of objects. These should make sense soon. Anytime you see something dash, it's usually the name of a special type of object called a set object. And there's more about that later. Okay, we've done the background. We've looked at RPSL objects. We've had enlightening and scintillating discussion on the person object. Fine, there's only another 11 objects to go, and we've got for Tuesday afternoon. Any questions on RPSL objects? Okay. Going to look now at contact information. As I said, we looked at the RPSL objects, very similar to what we saw before, attribute value pairs. Object names have special rules, and certain reserved words and prefixes can't be used for object names. This is the rest of the milestone. Contact information. Going to look at person, role, and maintainer quickly. Person, role, maintainer. This is a person object. This upper red box here is person contact information. This lower red box is auxiliary information. Now what I want to draw your attention to is this is common to all objects. Okay? All types of objects usually have a maintained by, a remarks attribute, a changed, and a source. And I know what you're thinking. Wait a minute, you told us that the order of the attribute can be in any order except the class key must be first. Of course, however, I've put it here just to show you anything like this, remarks, maintained by, changed, and source, also admin C, tech C, those attributes are common to all objects. However, there is information that is usually specific to that type of object. So in the person object, this is information specific to a person object that only appears in the person object. This kind of information appears anywhere. Yep. Person object, information about technical or administrative contact. I put that in there to say the Internet Routing Registry is not a white pages service. Okay? You can't put yourself in there just because you really feel your friends should be able to find you. It's about technical or administrative contacts in the Internet Routing Registry. I'm going to start this all over again. The NIC handle is the primary key. The role object is very similar, except the role object refers to a role or function. Okay? And what some registries say is that role objects should be used rather than person objects as much as possible. Obviously, if the role object is built on top of the person object, a role object points to person objects, but it means that if you are referring to a role, then if anybody in that help desk or operations center changes, you only make a change in the role object. You don't have to go around changing NIC handles in every other object. Okay? The best thing is, for example, if you have a technical contact, point it to your role object called Network Operations Center. If people join the center or leave the Network Operations Center, you only need to change one object. But if you have a technical contact pointing to a particular person, and that person leaves the organization, you've got to find out where this person is referred to in all your records and change them. Auxiliary information is in all object types: description, text C, admin C, remarks, and notify, changed, and source. Source refers to the database, for example, RADB or whatever. It's where the object was originally created. Yeah? The source attribute refers to in which database the object was originally created. Should also say again, admin C and tech C is not in the person object, at least not in some implementations. Maintainer object is very important from a point of view of authentication. Maintainer, you see the class key, it comes first and it uniquely identifies the object. These two are to do with RPS security, Routing Policy Specification Security. I'll talk about them later. And there are some differences in the implementations between the various databases. Not many, but some. Just watch for them. This is one maintainer object. This uniquely identifies this maintainer. This is maintainer maintaining itself. PGP key is the type of authentication. I'll say a little about that in a moment. So on. It's an old object, but I use it to demonstrate the idea. Now, I said I wouldn't talk about the right database, and every second slide seems to be about the right database, but this is just to show you with this RPSL security referral by. This is a root maintainer object. Basically, it's the maintainer from which all other maintainers are created. That's what this really means. So if you were creating a database from scratch from the beginning, you would put in this root maintainer first, and all other maintainers are created referring to this maintainer. Okay? There's a encrypted password as well. That is an old object, by the way. Also, you have this RPS security. RFC 2725 brings in this new attribute referral by the maintainer that created this maintainer, what some people call the mother of all maintainers, or the root top-level object. It has a new attribute called auth override. I haven't seen this implemented anywhere yet. It's the date after which a maintainer can be modified. But only the maintainer in referral by can do this. This is really if you find there are objects in the database they're broken, and the database administrator is trying to contact the person responsible for this maintainer, and they're getting no answer. So this is a functionality put in there saying, okay, we're getting no answer from this maintainer, we've got to do something. However, I haven't seen this implemented, but it is in the specification RFC 2725. Now, I showed you a few moments ago that you can have an authentication. Okay? Authorization is who can do something. Authentication is proof. So you could be authorized to enter Canada from another country. What's the proof? Well, if you were really famous, it would just be your face, and you just customs and immigration, hi, just come straight through. But on the other hand, you have to show a passport. That's the authentication. And in maintainers, we have several types of authentication. The first is none, means no authentication check done whatsoever. I would not encourage you to use authentication method none.
Stronger message.
Okay, don't do it. Okay, don't do it. Don't use that. The next one is mail from. Okay, now this is based on the mail header of your update. Remember I said to create or modify or delete an object in one of these databases, you send in an email. That email has a header. One way of authenticating the update is the mail header. Now, who would possibly forge a mail header? How difficult is it to forge a mail header? Okay? This is actually a regular expression match. So an example is mail from everyone at nanog.org or mail from .star@nanog.org. This is being deprecated in some registries. I would say to you, don't do it. Okay? I would call these authentication methods, but in double quotes, okay? The next one is crypted password. This is where in your email with your plain text object you put a password. You actually put an attribute password, colon, and then you put in a clear text password. You send that in your email. The clear text password is not published in the database, but the crypted password is, and you have this as an authentication method. I think I showed you this here. Here is the crypted password. This is based on a clear text password. So if I was sending in an object, in the email I would put in the clear text password, and the database would compare it with this crypted password. Okay, and it's produced by the Unix crypt routine. Now, as far as I know, some people are actually moving to MD5 crypted passwords as well, and I would encourage you to use that rather than crypted password. But it's there. That's what's there. These, as I say, I don't know, it's a database administrator's idea of a joke or something like that. Just don't use them. Just don't bother. And then there's the strongest method, which is called PGP key. Now, although it has PGP as the title, you can, in some implementations, use GPG. So you would have this, as it were, the PGP key ID. As far as I know, this is part of the PGP fingerprint. It's part of it there, that number. It comes from RFC 2726. If you want a little bit more information, it's put in this key certificate object. As I said, this key certificate object is not actually in the RPSL RFC, but it is described in this. An RFC implicitly refers to it. GPG and PGP public keys can be used, but check with your database for which they support, because I think some registries, some databases support one but not the other. Some support both. And what this means is that you put your object in the email, you sign that email with a PGP or GPG, a digital signature, and you send it off to the database robot. And that's the authentication. I should say, I'm not going to say where this happened, but somebody once sent in to database administrators a question. They said, I can't update my object. I send in the digital signature and I cannot update the object. What's wrong? And the database administrator said, well, send us your digital signature perhaps, or send us your update, we'll have a look at it. And the person sent in a JPEG file of their signature, you see, digital signature. So the database administrators had serious pain here, you know, and when they recovered laughing, they said, okay, who's going to reply to this person? Said, well, you're the most experienced, you reply. I said, no, you're a junior, you reply. So, oh boy, what do we do here? But there you are. You can digitally sign your updates to the databases, and I would encourage you, perhaps even more than, I don't know if there's a stronger word than encourage, but I would encourage you to use that. I would say be careful using many authentication methods in a maintainer, because logical OR is used. Okay? So if you have in your maintainer, you can have, remember, quick flashback, auth can be multiple. If you had auth PGP key and then auth encrypted password, either of those works. You don't need both, you just need one. Now, it has been seen that some people put in auth PGP key and then auth mail from, or auth PGP key and auth none. Okay? Remember, if you have auth specified more than once, any authentication method works. Nothing wrong with having multiple different PGP keys, but be careful having something less strong. Okay? It's logical OR is used. Any one authentication method works. And as I say, avoid using authentication none, avoid using authentication mail from. I would say just do not. Forget about it. And as I say, I think some databases are actually deprecating this, but you'll see it in the RFC. This one as well. Any questions on contact information in the Internet Routing Registry? Yeah?
It is a good idea to deliberately choose an email address that is not your normal mailbox or the change line. Our observation running 1A1 B3 services is that spam grading is possibly the majority yes. Since change lines will often build up in your record, you are publishing multiple addresses that people will spam you. So you should choose addresses that you can filter and return and deal with sensitive.
Okay. That's a very good point. That's really an implementation detail, but yeah. Okay. Thing is, I'm just watching my time and how little I've got left, so have to move up a gear or two. Specifying routing policy. The next part, we have looked at background RPSL objects and contact information. Let's look at specifying policy. Look at internet routing, the OGNUM object, the route set object, AS set object, AS path regular expression, composite policy filters, how to specify actions, community-based policies, and ambiguity resolution. Now, in internet routing, basically interior routing is metric-based, but exterior routing is policy-based. Can A use ISP3 to reach B? And it's based on BGP. This is 5 seconds on internet routing. Okay, we're done. So, this is a format, this symbolism I use throughout inter-autonomous system topology. You have big backbone providers here, regional ISPs here, and these are other ASs. This looks like some molecule for something you really don't want to know about, but that's the diagram I use throughout. AS, autonomous system relationships, you can have customer, regional provider. The provider forwards traffic and advertises customer routes, or you can have peer-to-peer for mutual benefit. The regional provider to backbone provider is similar to customer-regional provider relation. And typical routing policies implement these kinds of relations and agreements. So we have AS level peering, and what we have here is AS1 is export to AS2 originates this route 128.9.0.0. AS2 exports that to AS1, and AS1 imports that from AS2. Okay, I think arrows might be going the wrong way there, but the idea is AS2 originates this route and exports it to AS1, and AS1 imports this route from AS2. That's what I mean by that. BGP routes use path attributes. These attributes are destination address prefixes. The AS path, the originator AS, a list of communities or flags, and some matrices like ME, multi-X discriminator, or pref. How do we express routing policy? Well, this is an example. Auxiliary information is not shown, but here we have import and export in default. The Opnum object expresses the routing policy, and this is an example routing policy. This is the template. The attribute Opnum takes a value AS number, which can be mandatory, it's single, and it's the class key, and it's first. And then we have the AS name, which is an object name, which is mandatory. Member of, I'll say a bit about that soon, import, export, and default. Import is your import policy, export is your export policy, default is your default policy. There are some changes between RPSL and RFC 1786. In the past it was called AS out, inter AS out, it's now called export. You might see old objects in documentation, AS out, inter AS out, it's now called export. AS in and inter AS in is now called import. Default becomes default.
By default, you mean something when it's just is not specifically specified?
Yeah, default, yeah. Policy in RPSL can be expressed in a variety of ways using prefixes, AS paths, communities, prefix lengths. So you've got not one, not two, not three, but 4 ways of expressing policy. There are feature attributes through its dictionary. RPSL defines a dictionary of attributes you can use. You've structured policy, and I'll give some examples of uses. And some implementations of RPSL do not implement the dictionary. So some prefix-based policy, here's an Opnum AS1, it exports to AS2 and it announces these routes, 128.8.0.0/16 and 128.9.0.0/16. These are examples, so AS1 is exporting, announcing these routes to AS2. And notice that filtering here is based on address prefix set. What we're saying is AS1 is announcing these routes and no others. Here you have a set of address prefixes, and this is the filter. Announce here is always followed by a filter. And this is looking at it from the other side, AS2, import from AS1 This should be accept, not export. It should be accept, ACCEPT, these. So this is my deliberate mistake, just to see if anybody spots it, okay? I often make deliberate mistakes. No, seriously, I'll change this. This is accept. This is what happens when you have to do stuff late at night. Okay, filtering is based on the address prefix set. What's the import attribute? Well, we have seen import and export in examples. These are the definitions. What we're saying is import from peering 1, action 1, from peering n, action n, except filter. This is the definition. The set of routes are matched by filter, and they're imported from all peers in the peerings. So you should see this is wrong, this should be accept, but this is the filter, and they're imported from this peer. Okay? And when importing routes at peering M, action M is done, I'll say a little bit about actions later. How do you choose a peering? Well, here's one with some kind of exchange point, an autumn AS1 from AS2 at 2.2.2, action set of pref equals 10, except AS2. Okay? Very simple policy here. So your peering, your filter, as it were, here, and this is your action. Choosing a peering again, AS1 from autumn object here. By the way, I have not shown all the auxiliary information like admin C, tech C, zone C, but import from AS2, action at 2.2.2. Here's my action, I accept this. And by the way, when I say AS2, I mean all the routes originated by AS2. So when you see in this context an AS number, except AS2 means all the routes originated by AS2. Here's another import policy. And as I say it here, in filter context, AS2 is routes originated by AS2. Yes, sir?
Would that explicitly deny all routes transited by AS2?
It's accepting everything that AS2 is announcing.
So that's the retain and transit?
As far as I know, yes. Certainly, actually, it would be originating. Definitely originating. Export. Okay, this is just the definition. And default. Okay, router uses a default policy if it receives the routes matched by filter from this peer. Okay? Examples of default. AS1 defaults to AS2 and uses 128.9.0.0/16. And AS1 defaults to AS2 and AS3, but prefers AS2 over AS3. I'll say a little bit more about actions later. This is just an example of default policy. Routing protocols. The default is the Exterior Gateway Protocol, BGP. The valid protocols are in RPSL dictionary. And this allows injecting routes between protocols and multi-protocol routing protocols. The idea of this dictionary is you can add in new protocols if you wish. Let's just go back to prefix-based policy again. Here's the example we had before, and the filtering is based on this address prefix set. So I'm announcing these address prefixes, but no others. This looks okay. What if you start announcing more routes? What do? This could get messy, this could get cumbersome, this doesn't really scale. So you have the route set object. This is the first of several types of set object we're going to look at. You have a route set, members, these are the members, description, some address prefixes. So this is the route set RS-red. The route set RS-yellow has members, this address prefix, but also this route set. And the description is a route set that includes RS-red. So here's a route set, and this route set includes that route set. So you should see it's scalable. And yes, in the sense that the members of this route set can include another route set.
But that's not a general list property, it's specific to this five-hole list.
Well, for route sets and AS sets, yes. Okay? And you see that these address prefixes are members of RS dash, this is a mistake, RS dash yellow. Okay, yep. 6, 8, no, my mistake. These are members of RS dash red. And this RS dash red is a member of route set RS dash yellow. Okay. I should say that a route set is a set of route prefixes. That does not mean it's a set of RPSL route objects. It's a set of route prefixes. Okay? This is the route set object template. You see the members attribute address prefix range, or a route set name, or route set name followed by a range operator, and this reserved keyword rs-any, which means all the routes, as it were, any route will do. Okay? In fact, I think it's all routes registered in the routing registry. Now, I don't know about you, but my watch says it's about 3 o'clock. So I'd like a nice cup of tea now. So what if we restart at what, 3:30? Okay. When we come back, I'll have to move up a gear, but some of these slides I think we'll just look at briefly. I'm more interested that you see the examples and that you think about that. So if we restart at 3:30. Okay, and I'm here for questions if you have any. Okay, I think we'll have to make a start. There are quite a few slides left, and I hope to finish on time at 5 o'clock, or as close as possible to 5 o'clock. Before I begin again, I just say we looked at the Internet Routing Registry, we looked at RPSL objects, we looked at contact objects and maintainer objects. Maintainer objects are to do with authentication mechanisms in the Internet Routing Registry. We're now looking at specifying routing policy, and you specify routing policy using the autonom object, autonomous system number object. And we were talking about specifying policy using route address prefixes, but we said if these get cumbersome, how do you add more address prefixes? And we talked about the route set object. Any questions on what I've said so far? First half. Okay? Well, I hope you're all fed and watered after the break, so now we'll press on. Feel free to ask questions. As I say, if you think you're running out of time, I'll answer them later. When you're talking about routes and route sets, a very useful thing in RPSL is range operators. This specifies an address prefix range, which is an address prefix followed by a range operator. There are several types of range operator. I don't know what you call this, up arrow or caret sign, followed by a plus, is the inclusive more specifics. This symbol is the exclusive more specific, so this is all the more specific address prefixes, including this one. This is all the more specifics, excluding this address prefix. This is the length n more specifics, up arrow n, and then up arrow length n minus m, the length n to m more specifics. Okay? Now, there'll be more about these later in an example, but what I want to talk about now is with route sets. You saw how in this route set object rs-red, I list the members, these three address prefixes. And I said that these three address prefixes were direct members of RS-red. But there is another way in which an address prefix can be a member of a route set. There is another way in which a route can be a member of a route set, and that is indirect members of a route set. So here is a route set. Remember, I've left out all the auxiliary information like TextC, maintained by, source, and all that. But I have this attribute here, members by ref any. Okay, members by ref any. We're just talking about route sets again, and we're just saying we described how you could have direct members of a route set because in the route set you list the members directly. There is a way of doing it indirectly using this members by ref. Now here I have a keyword any. Let me give an example. Here are two route objects. They describe routes. This route object is maintained by MNT-ANS. This route object is maintained by this maintainer. Okay? Therefore, these two routes, or the routes represented by these route objects, are members of this route set. This members by ref here points to a filter. The value of this filter can be any, or it can be a maintainer. Okay? So here I am saying that in this route set, any route that wants to can be in this route set. So here I have these maintainers, and these route objects say member of, I'm a member of this route set, and they are. Because the any filter here matches any maintainer here. It should become clear when I show restricted indirect members of route set. Here I have the same route set, but now I've put in members by ref MNT-ANS and MNT-Cengiz. These are now maintainers. Look at these two route objects. Both of them have an attribute member of. Both of them say they're a member of a route set. But this is maintained by MNT-ANS. This is maintained by MNT-Curtis. Now what we're saying is here that this route object says that this route is a member of this route set. But it's maintained by a maintainer that is not in this list. Therefore, this route, the route represented by this route object, is not a member of this route set, even though it says in its member of attribute that it is. That's not enough. Okay? What we're saying here is this is a filter. You can open the gate and put in any. And any route object, any route represented by a route object can be a member of this route set. Or you can put in a filter, a list. This is a list value of maintainers. And only routes represented by route objects, which are maintained by these maintainers, can be a member of this route set. Yes?
Is this a mechanism that would stop that route object being admitted into the database, or does it say it can be in the database, it's a legal object, but when you try and use it, first of all, prevent it showing up?
Good question. In RPSL, this object can be in the database. In RPSL spec, this object can be in the database. But in implementation details, I think some databases would reject the creation of this object completely.
You can make the change afterwards, but you can't go through it to leave.
Yeah.
Okay, thanks.
But the thing is that what we're saying here in RPSL, this route, the route represented by this route object says it's a member of this route set, but the maintainers don't match in this list. Okay? The maintainers don't match. So it's a bit like you going to a club, exclusive club in London, and you say, good afternoon, I'm a member of the club. And they check your name on the list and they say, oh, do come this way, have a newspaper, have a cup of tea. On the other hand, they can check up your name and you say, I'm a member of this club, and they check the name on the list and you're not. And instead of saying, do come this way, please, you say, you are, okay? So this is a way of restricting members of route sets. It's also a scalable way of populating a route set. So in other words, you could put in, say, the maintainers of customers here, and only your customer routes can be in this route set. Here are direct and indirect members. I have the route set, here are the members listed explicitly, and here is members by ref. Okay? Here we are. This is one of the members that was listed explicitly. This is not listed explicitly, but because the maintainer matches this here, the route represented by this route object is a member of the route set. Okay? What I'm trying to say is member of is not enough. If you put member of in a route, that doesn't mean this route is in a route set. Either the maintainer must match or the route must be directly listed in the object, in the route set object. Now I've written it down here. The member of attribute of a route object is an extra way to specify the members directly. If an address prefix is listed in the members of attribute of a route set, then it is a member of that route set. The route object corresponding to this address prefix does not need to contain a member of attribute referring to the set name. And what I say here is only use the member of attribute of a route object when using the members by ref attribute in the route set object. Okay? Route, auth-num, and INET router objects have a member of attribute. This is not enough to make them members of the sets. The set object has a members by ref attribute and members. And if members by ref is absent, members is used. Actually, both are used. I have a note to myself written here. Database software sometimes checks the validity of a member of attribute. If you're creating a route object and you say member of somebody else's route set, some implementations check if this is true. If it's not true, they reject the creation of a route object. However, all the RPSL spec says is you can have this here even if it's not true. But that doesn't mean that your route object is a member of the route set. Now I give an example of a route set object. Here is an auth-num object. Question, is it possible to read the text in here inside the red oval? Some people tell me they have problems reading it from the back of the room. Here is the auth-num object AS1 export to AS2, and I announce these three address prefixes. Well, I create a route set object rs-red. Here are the members listed directly, and now I can rewrite my auth-num object AS1 export to AS2, announce rs-red. And rs-red means the routes represented by this route set, and auth-num AS2 import from, another deliberate mistake, AS1 except rs-red. I should say I will correct these errors. What I find interesting is that sometimes I've corrected them already, but okay. Import from AS1 except rs-red. Here is another example. It's the same thing again. Announce rs-red except rs-red. Here's an example of range operators and route sets. It's a route set called RS-Martians. I would encourage you not to import these routes, okay? These are all the usual suspects, the stuff you probably don't want to import. So here I've listed the members, and here are the range operators at work. Now, some people have even suggested that this should be part of the standard, okay? That this should be a standard object in RPSL, and it should already be in a database, rather than letting somebody create it for you, okay? But I'm using it here as an example of range operators and route sets. Here is the route class, or the route object. Here is the policy information, and I'll just say here, the class key is route, but the key that uniquely identifies the route object is route and origin, and we can get into all this discussion all over again. But here you have route and origin. This is, as it were, these keys uniquely identify the route. What we're saying here is this address prefix, this route 128.97.0.0/16, is originated by AS52. Okay? And I have left out admin C and tech C as well. There is an issue in some implementations whether admin C is mandatory in the route object or not. I think that will be changed. This is the route class template. You see the class key for the route object is both route and origin. It's that pair, that tuple. Okay? I'll say a little bit about these at the very end. This is sort of advanced use, inject components, aggregation boundary method, export components and holds. And here is the member of attribute. It's a list attribute, it's a list value pointing to route set names. Okay, what's the route object? It's a subset of a route, but it's not actually a route, as it were, itself. A route object is a subset of a route. The route and origin attributes are the class key. So here are two route objects, same address prefix, different origins, so there are two different routes. Okay, it's for multi-homing or whatever. Using AS numbers and policy, what I'm trying to say here is, notice that I have a route object here, origin AS1, another route object, origin AS1, and AS2 import from AS1 except AS1, and the opnum object for AS1 is export to AS2, announce AS1. And what we're saying here is, in this context here, AS1 means the routes originated by AS1. Okay? So when you see except AS1, it means the routes originated by AS1. Okay? When I talk about the tool set, you should see a better example of that. So this really is a route set or a filter context here. Now, it can get cumbersome. What if AS1, as it were, is some kind of backbone provider with customers? And now some people say, what is this meant to be? The quick, stupid answer is it's something we see in Star Trek or Star Wars. You know, it's one of these spaceships that's going to come along. But anyway, this is just a diagram, and what we're saying is opnum object AS1, export to AS2, announce AS1 or AS3, blah, 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 AS6, logical operator, and opnum AS2, import from AS1, except AS1 or AS3, dot, 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 AS6. Now this could get a little bit complicated. This mightn't scale. And remember, these AS numbers refer to the routes originated by these ASs. So, we have a solution, AS set objects. Here we have AS set, AS1 colon AS dash customers, members AS1, AS3, AS4, AS5, AS6. Here they are. And we have the opnum object for AS1 export to AS2, announce AS1 colon AS dash customers, an opnum object for AS2 import from AS1 except AS1-S-customers. Now, I know what you're thinking. What's this AS1 colon? I'll say a little bit more about that later. I'm afraid with this presentation you have to kind of work through it all first once and then come back and look at it again. AS set names can be hierarchical. I could have just called it AS-customers or AS-AS1 customers. But one of the things in RPSL is it allows you to create a hierarchical name. The idea behind that is only the maintainer, only someone who knows the authentication method of AS1 can create an object called AS1:something. Okay?
So in this context, colon is part of the syntax of the name of AS.
Yes.
Special, and it is used to denote
hierarchical.
Have hierarchy, have meaning, have access.
Yes. It's for creation, yes. Normally AS sets can be called AS-something. But this is special. I have put this in here. It's a hierarchical naming method. All I want to say is that only somebody who understands a particular authentication method for AS1 can create an object with this name. Okay? What it does mean is that you can have customers, but only you can create an object, an AS set with this name. Okay? If you are AS1. Here is the AS set object template. I'll leave the templates for you to read in the draft or the RFC. I just say here is AS-any. Notice members, AS-any means you can have any AS can be a member of this AS set. And members by ref here is any. Okay? So these are filters. Okay? So you can allow every AS in the routing registry to be a member of your AS set, or you can list it explicitly with either AS number or an AS set name. And again, here's a filter on membership. Here are some indirect members of an AS set. I have an AS set called AS Alkmaar, members by ref any, and I have an Autonum AS3333. It's a member of AS Alkmaar, maintained by this maintainer. Does it match the filter? Yes. Any matches everything. Okay. This Autonum is a member of this AS set. This Autonum object says it's a member of AS Alkmaar. Does this maintainer match any? Yes, it does. So this Autonum, the AS number represented by this object, is a member of this AS set. So, we can use AS set objects like this. Here I have an AS set called AS6:AS-customers here. And here I have an AS set AS1:AS-customers, and its members include this AS set. So I have this AS set appearing, sorry, I beg your pardon, I have this AS set appearing as a member of this AS set. And remember, only somebody who knows the authentication method for AS6 can create this object, and only somebody who knows the authentication for AS1 can create this object. Okay?
In this first example, there is no object that has a simple name, AS-.
I know, there isn't.
No, I'm just asking.
Yeah.
And that's exactly how it should be. Yeah?
Yeah. What I'm trying to say is that here is the simple example, AS-something. Okay, using AS set objects, as I said before, here we have an AS set that is included in another AS set. And one of the things you can do with this is, for example, because you can use your AS set objects and Autonum objects, the Autonum object is something that's probably only changed, modified by your key staff, your best staff. You don't want anybody else going in and changing this Autonum object. In the previous version, RFC 1786, Write 181, if you changed your customers, if you changed to who you were announcing routes or accepting routes, you had to change this Opnum object. Here, you only change this. So what it really means is your operations staff change the Opnum object. Somebody else can change this. One of the advantages of RPSL is you can delegate some tasks to different people rather than having all your network operations staff changing this. Okay? Any questions on AS set objects so far? Okay. What if you have more customers? Now this is really growing. This is like the boom days of the year 2000, you know. Opnum object AS2. Import from AS1 except AS1 : AS customers. All these. Import from AS3 except AS3 : AS customers. These. Import from AS4 except AS4 : AS customers. These. This is beginning to look a bit cumbersome. But we have a solution, peer AS. We create an AS set object, and the members are AS1, AS3, AS4. And we now have in our Opnum object for AS2, import from AS2 : AS customers, that's here, except peer AS : AS1 - AS customers. This is a placeholder, a counter that loops over the members of this AS set. That's the idea there. Okay? You have a keyword, peer AS. It's used in the import attribute only instead of the AS number of this peer AS. And it's useful when using AS expressions. So just to show you, instead of having to do this, you only have to do this. RPSL is trying to say an awful lot in a very small amount of text. Can you see that? RPSL is trying to say an awful lot in a very small amount of text. So peer AS refers to the members of this AS set, and you replace peer AS with these. That's the original example. This is what you have now.
You have to manage that community to say,
yes.
I demand of you that you create a thing called AS-customer.
Exactly.
My lead-in, and then I can use it.
Exactly, yes. You have to, your peers must adopt this format, but if they do, look what it solves.
Right, and it's not that the string is AS-customer, it's a string you choose. And you can say whatever string I choose, you must implement your AS1 tag.
Whatever the tag
is AS1 tag.
Yeah.
Right.
But it does show that it is powerful. It makes things a little bit easier to read. There are some predefined set objects. Notice they are case-insensitive. RS-ANY is all the route objects in the routing registry. AS-ANY is all the autonomous system objects, the Opnum objects in the routing registry. And as I said before, in the route set context, in the filter context, ASX is the routes originated by ASX, and an AS set, AS-X is the routes originated by the AS's and AS-X. What I'm saying is, simply, this is a filter. This is a filter. And when you see AS-X in a filter like that, it means the routes originated by that AS. And if you see an AS set there, it means the routes originated by those ASs in ASX. Now we have a more complex example. And what it means is filtering based on AS paths. And you can have AS paths that start in AS1 and end in AS8, so we have this regular expression here. No prefix filters here at all. No address prefixes. It's filters based on AS paths. And we have AS path regular expressions. And they mean more or less what you think they'd mean. 0 more occurrences, 1 or more occurrences, and so on. Beginning of path, end of path, X or Y, X followed by Y. What these are policy filters, but only when this expression is within these symbols, less than sign and greater than sign, sometimes called the spaceship operators. Any of you who wasted your computer science training on playing or indeed writing space games would kind of make spaceships out of these and X-wing fighters and all kinds of stuff, and we call these the spaceship operators. But I'm sure all of you had focused your minds in your studies studiously and never did anything like that. The regular expressions, when I talk about AS regular expressions, I mean the alphabet of AS numbers. I don't mean Unix-type regular expressions. I mean regular expressions only in the context of AS numbers. AS path regular expressions can check things like a BGP AS path or Inter-Domain Routing Protocol, or RD path. And we use regular expression operators, as I've just shown. Here is an AS path regular expression example. Here are the spaceship operators. And this expression here matches any of these. Okay? I won't spend too much time with that. Here is AS path based import export. This is the Autonome object for AS2. This here is the Autonome object for AS2, but I've removed a lot of attributes just to make it fit on the page. There are no route prefixes here, but I'm saying from AS1 you can accept this, or from AS1 accept this regular expression. And notice I have an AS number here, and I also have an AS set name here. Okay? I also have an AS set name there. So this can make it very powerful and very compact. We have composite policy filters. Now, these equal signs are not part of RPSL. I use them in my presentation just to say that AS1 originates these routes. RS-red has these routes as its members. And so AS1 or RS-red includes these routes. This is the AND operator, and this is the AND not operator. The logical operators do all the things you would expect them to do. Okay? So this is not is negation, AND is intersection, this is union. Okay? Composite policy filters. What would an example be? You might have something like this. Autonome object AS2, import from AS1, accept AS1 or RS-red, and not this. Okay? So here it gets interesting. We can use these composite policy filters to have a tightly defined routing policy. And what I'm saying is AS numbers and route set and AS set names here refer to the routes. Remember what we're saying these things represent. They represent routes. They're filters. At least they represent that in RPSL. Here is an example. Here is the route set RS-Martians. Autonome object AS1 import from AS-any. Remember this again. This means any AS in the routing registry, except any and not RS-Martians. Now what you might find is you would say except from this customer, accept the routes from this customer, and not this. Yeah? You'd filter all the bad stuff. You can have prefix length-based policy. Autonome object AS1 from any, except any, and not this. This is private address space. So you're saying from any other autonomous system, accept any routes, but not this. Now, I'm sure none of you have ever got an email from somebody complaining of spam, saying, I got email from this, please do something about it. Particularly if you work for a regional registry, you probably have this object in your database. Okay? There's a story behind that, but I don't have time to tell it now. But this is just an example of prefix length-based policy, and using your logical operators as well. Okay, we've talked about some policies. What if you want to set some actions like preference and cost and community? So, we have an Autonom object AS4, it's connected to AS1 and AS3. There is a slow link between AS4 and AS3. And what we're saying is import from AS1, action pref equals 10 except any, and import from AS3, action pref equals 15 except any. Now this is important to say, the smaller the value of pref, the higher the preference. In RPSL, pref is 65,536 minus the value of the BGP local pref. Okay? I think of this as cost. The lower this value, the higher the preference. But RPSL calls this pref. But this is a situation where the lower the value of pref, the higher the preference. Okay? Now you can specify actions. You can use them to set or modify route attributes, to instruct routers to do special operations, or to do route flap dampening. Which route attributes are specified in the RPSL dictionary? Okay? As I say, some implementations do not have the dictionary, so you want to check which BGP attributes can be set or modified by an action statement. The syntax of a policy action is either x.method followed by arguments or x operator argument. It's always terminated by a semicolon, and composite policy actions are possible. They're evaluated left to right. This is just a template for how you would do this. Import from somewhere action XXX accept, export to somewhere action XXX announce. Here are examples of actions: community.append, no export 102503561:90, close bracket, colon. Here's another example: community.delete, no export, and aspath.prepend. So these are BGP actions. Specifying actions, for example, Autonom object AS4, export to AS1, announce AS4, export to AS3, action aspath.prepend AS4, announce AS4. So this is an action specifying. From choosing a peering, well, here we have AS2 and AS1. Autonom AS1, import from AS2, accept AS2. In other words, the routes announced originated by AS2. And I can also set an action here. Autonom object for AS1, import from AS2 at this router 2.2.2.2, action pref equals 10, accept AS2. So I'm setting a value, a preference for the routes I import here. This would be an exchange point. And this is what you might do in practice. Autonom object for AS1 from AS2 at 2.2.2, action pref equals 10, accept AS2, and from AS2 1.1.1.2 at 1.1.1.1, action pref equals 5, accept AS2. So in other words, if I go back, I'm choosing between these peerings. Okay, I'm saying which I prefer most, and if that's not available, what I'll take next. And the lower this value, the higher the preference. Okay? Now we have community-based policy. AS4 wants AS2 to prefer this path. And AS4 knows that AS2 prefers routes with no community, first of all. Next, community 2:90. After that, community 2:80. And lastly, community 2:70. Normally, this refers to the AS that's setting the community, or the AS that define the community. These are AS2's policies. From AS any, action pref equals 30, except community 70. Here is the action statement terminated by a colon. We're setting a preference value of 30 for routes with this community 2:70. From anywhere except we accept route import from AS-any, action pref equals 20, except community 2:80. And import from AS-any, action pref equals 10, except community 2:90. And from AS-any, action pref equals 0, except any. So we have implemented here in this Autonome object this policy. This is the order in which AS2 prefers routes, and this is the Autonome object. And I hope you see just how difficult it really isn't. Okay? So what does AS4 do? AS4, the Autonome object for AS4, export to AS1 action community 2:90 to AS3 action community dot equals 2:80, announce AS4. And this is another way. I don't have export attributes here. I've condensed this a little bit to show you this can be done. Okay? So I'm setting these actions here, I'm setting these values to community. I'm appending this value to the BGP community attribute. How do you resolve ambiguous statements? If you have two or more peering expressions that describe the same peering, which is used, RPSL talks about the specification order rule. The first peering specification is always used. The first peering specification is always used. Here's Autonome object AS1. Import from AS2 action pref equals 2, except AS4. Import from AS2 action pref equals 1, except AS4 or AS5. AS1 accepts AS4's typo here, should be an F. AS1 accepts AS4's routes from AS2 with pref equals 2, and AS1 accepts AS5 routes from AS2 with pref equals 1. So the first one is used from AS2 pref equals 2, except AS4. Specification order rule. Okay, any questions on specifying policy? Okay, that's the longest single section in the tutorial. So look how far we've come. We've done background, RPSL objects, contact information, specifying policy using Autonome objects, route set object, AS set objects. We talked also about hierarchical objects there and peer AS. We're now going to look at set objects, and then we look then at the Internet router object, routing policy, system security, and some advanced features. So, set objects. So far we have seen the route set object and the AS set object. There are others. A set of routes and its set objects describe sets of routes, autonomous systems, etc. Route set, AS set, filter set, peering set, and router set. They specify members either directly or indirectly. These are the ones that specify members directly and indirectly. Route set, AS set, and router set. set names, AS-customers or RS-partner. I mentioned, however, that you can have hierarchical set names, a sequence of set names and AS numbers separated by colon. At least one component must be an actual set name, but when you have set names, all the set name components must be of the same type. So you can't mix RS sets and AS sets in the same hierarchical set name. Okay? But remember we talked before about this colon. It's to do with authorization. It's the maintainer of AS1 controls AS1 colon AS customer. It actually controls the creation. Now, what I'm saying here, it's actually this, the maintain lower. And that this, I'll talk about this later, this maintain lower attribute, or the maintain by, controls the creation of this. What it means is, in this, if you want to create this object, you must satisfy the authentication specified in the Autonome object for AS1. It's specified either by this special attribute MNT lower or by main MNT by. More generally, if you have this object here, AS1 colon AS RS-export colon AS2, only the maintainer of this object can create this object. Okay? But only the authentication specified in this AS, in this Autonome object for AS1 can create this. And Autonome objects can have this value or this one, MNT lower. If you're not sure what MNT lower is, don't worry, I will talk about it later. But I just wanted to flag the idea of hierarchical set names. This does, just bear with me, and I will talk about this. Just saying that hierarchical set names are possible. Now we look at filter set objects. Here's the filter set, FLTR-red. Here is the filter. Here's another filter set, FLTR-green. And the filter is AS1 or filter-red and AS2. And this, within the spaceship operator, is the AS path filter. And it matches any route whose AS path contains AS2. Remember, within this spaceship operator, you're talking about an AS path filter. Now, some people tell me that when the arrows are pointed like that, it means Darth Vader's TIE fighter, but I wouldn't know anything about that. But this means AS path filter. When you don't have the spaceship operators, it means something else. It means the address prefixes originated by the AS number. But this is an AS path filter. Okay? A filter set object defines a set of routes that are matched by its filter. This filter set object defines a set of routes that are matched by the filter. And there is no members attribute. Okay? There's no members attribute. It's just filter. And as we said before, you can use the name of a filter set in a filter attribute. The filter attribute defines a policy filter, and a policy filter matches routes. Any BGP path attribute can be in the filter. You should look at RFC 2622. Look at the RFC again. And we include these ones: any or an address prefix set or a route set name, an AS path regular expression, that was in the example, composite policy filters, routing policy attributes, or another filter set name. So here you can specify a filter in a filter set object. And I think I gave, this is the example of using a filter set name in a filter attribute. This is what I say here. any BGP path attribute can be in the filter, and you can also have a filter set name. Okay, you can have a peering set object. This defines a set of peerings. The peering set name begins with a reserved string PRNG dash or hyphen. The peering attribute defines a peering used to import or export routes, but there is no members attribute. There is no members attribute, but you do have peering attribute. So here is an example: peering set PRNG dash red, peering set PRNG dash green. This peering set has this peering and this one. So you can have peering sets. The names of a peering set can be in the peering attribute of another peering set object. So here we have the Autonom object AS1 from peering green except this. Okay, now see what RPSL is trying to do. They're saying an awful lot in a very small amount of text. Okay? A template of this peering object is in the RFC. Okay? What we're saying here is this router 9.9.9.1 imports 128.9.0.0/16 from, don't think I have the diagram, 9.9.9.2 and 9.9.9.3. I think I'm missing a diagram here, but the thing is, it's very condensed, very compact. You can have router set objects. Here is a router set. Router's red. And we're back now to members and members by ref. The members attribute is router1.isp.net, router2.isp.net, members by ref, red-MNT. And here's a router set, router green. Here are the members, router3.isp.net, and this other router set, routers-red, members by ref any. Okay, the same rules about members by ref and all that we talked about in router sets and in AS sets apply here. Same thing as before. Router sets are RTRS dash. So this route set object here includes router 3, router 1, and router 2. Okay, it's nested, very compact. This is a template. I've left out all the auxiliary information just to show you that the members can be INET router object names, route set object names, or IPv4 addresses. You can read a bit more there in the draft. Now, milestone, where are we? We've done background, we've done RPSL objects, contact information, specifying policy, set objects. We're down to the Internet router object. There's two more things after that to do: routing policy, system security, and advanced features. So the Internet router object. This is an Internet router, amsterdam.ripe.net, local AS, AS3333. These are the interface addresses, mask length, and I've omitted auxiliary information. This attribute is a valid DNS name of a router. Okay? Now, one attribute I have actually left out there is alias. So you can use, as it were, a canonical DNS name for the router. But in the example, I've just, for the sake of brevity, left that out. Here we have our interfaces, more detail. This is the template again. And we also have peering information. Here, the peer attribute, and again, member of router set name. So do you remember we talked about router set objects? Well, an INET RTR object can point to a router set name. A little bit more about this, just some detail here. The interface address is the IPv4 address, mask length, integer, and then the action, and these are what the peer attributes can be. And protocol is usually BGP. This is a slide that doesn't seem to say anything extra. Okay. So I think what I said here for myself was this protocol, if it's used, only the peerings and the corresponding peering set that are with this router are included. Okay, we're now on to routing policy system security. Not all implementations have this, but I'm going to spend a few slides talking about it. Before I do that, any questions on INET router objects? Okay, routing policy system security. I'm going to talk about the background, AS block, maintain lower, that I mentioned a few moments ago, MNT routes, referral by, and auth override. Routing policy system security, sometimes called RPSL or RPSL, specified in RFC 2725. It discusses data integrity and security in the Internet Routing Registry. Okay, we have this routing registry. How to know we can trust the data? Well, we have one new object called AS-block. Notice I call this by another title, RPSL. One new object, AS-block. 4 new attributes, maintain lower, maintain routes, refer by, and auth override. This is a new object in RPSL or RPSec AS-block. You have a range of AS numbers, a description of what it is, and remarks, and so on. I should say, as far as I know, right document 185 has been changed. These document numbers either are being changed or have been changed, so don't worry too much about this. The important thing is you have an AS block number, and one of the ideas they discuss in the RFC is that at some point you would create an AS block object, AS0 to AS65536. That would be the root AS block object. Okay? So a regional registry that was setting up a database at, as it were, time t equals 0 would create an AS block object with AS0 to AS65536. Stop people creating bogus AS autonym objects in the database. This AS block object is used by regional internet registries. It shows the delegation of a range of AS numbers, and it controls the creation of autonym objects through the maintain lower attribute. Once the autonym object is created, this attribute has no further effect. So all you're saying here is this AS block object with this attribute controls who can create autonym objects in the database. Once they're created, the maintainer, the owner of the autonym object, can then change it. But this controls who can create it. It also controls the creation of more specific AS block objects. Remember, this is hierarchical object creation. We have new attributes in RPSL. I'm sorry, I should have changed that to the RPSec, but I remember the RFC as a draft is RPSL, and these new attributes increase security, and the special ones are MNT lower, MNT routes, referral by, and auth override. We're now going to look at each of these in detail. The maintain lower attribute is used in AS block, auth-num, inetnum, route objects. Inetnum is an object that exists in some databases that describes IP address ranges. This attribute points to a maintainer object. It's exactly like maintained by, but it controls the creations of objects underneath the route object. That's maintain lower. If maintain lower appears in an AS block object, it controls the creation of more specific AS block objects and controls the creation of autonym objects. If this attribute maintain lower appears in an autonym object, it controls the creation of hierarchical name objects. Do you remember what I talked about AS1 : AS customers? Well, this AS set object, AS1 : AS customers, that is controlled by the maintainer specified in MNC lower. Okay? I wanted to say something extra. MNC lower in the autonym object controls creation of hierarchical name objects. If maintain lower is absent, then maintain by is used. You would ask, why have maintain lower if you can always use maintain by? The idea there is that you can have different authentication schemes in these two maintainers, and you can give the authentication key to different people in your organization. Okay? Whoever has the key to the maintain by maintainer can change the autonym object. Maybe you're happy with that, maybe you're not. However, the people who only have the key to the maintainer, the MNC lower maintainer, can only create the hierarchical named objects. What RPSL tries to do is allow you to delegate authority to different people in your organization. Okay? And in route objects, this gets complicated, but there is an example coming. MNC lower controls the creation of route objects with more specific address prefixes. The what? You say, I'll show you what I mean later. But MNC lower controls the creation of route objects with more specific address prefixes. In other words, you can have a route object and you can control who creates more specific route objects underneath your route object. So here's an AS block number of AS block object again. Here is AS block and MNC lower. Here's an example. This autonym object here can only be created by this maintainer or by somebody with the key to this maintainer. Okay? If the AS block object does not have this MNC lower attribute, then you use the MNC by attribute, which is not shown. But what you're saying is this object can be maintained by one maintainer, but a different maintainer can control the creation of objects underneath. It makes sense. You don't necessarily want everybody in your organization to be able to change this object, but you might want some people in your organization, if you're a regional registry, to be able to create AS numbers underneath this. That's what it's saying there. The autonym object I maintain lower. Here I have an autonym object AS1 maintained by an MNC lower. This AS set object AS1 : AS customers can only be created by the person or persons with the key to this maintainer. If there is no maintain lower object in this autonym object, then this maintainer, MNC by, is used. But as I say, maybe you don't want that. Whoever has the key to this maintainer can change this autonym object. Maybe it's better to only have a few people able to change this autonym object, but to give other people the ability only to create these. Yes?
In this situation, would AS1 maintainer have the ability to change the lower ASs as well?
Not necessarily. What you're just saying is to create an object with this name, AS1 : customers, you have to have the key to this maintainer. If this attribute isn't present, you must have the key to this maintainer. But it's just creating an object with this name, hierarchical name objects. Does that answer your question?
No, not quite.
Yeah, George, sorry?
I think it relates to this. My understanding of the implementation specifics of this is that the man by doesn't transit when you have a main blower. So in the case that it's both the main by and the main blower, the main by does not have the right to maintain a subsidiary object. Only in the case where, because there is no main blower,
Yes.
the main by is used as default, the main by has right. So your right is not transited once you define set with the main blower.
Yes.
Into your own right.
Yes.
So then, couldn't the mate by rewrite the OTNUM to exclude the mate lower and then have the
Yes.
rights?
You could.
Okay.
That's the thing, but you only give this to a few people. The idea is you don't give the keys of the shop to everybody who works for you. So the thing is, MNT by only works when MNT lower is not present.
If you want the value currently in that example that MNT by to have rights, and
Yeah.
explicitly as a value in limits lower,
Yeah, exactly.
and then you have to send it rights.
Yes. But what I'm saying here is, or what I hope to say here is, if this MNT lower is present, the key to this maintainer can create an AS set object with this name, but not this one. If this attribute is not present, then this is used. Yeah? Does that answer the question? Well, what the idea here is that you can give the keys to these maintainers to different people in your organization, or you can give them to the same people. But it's as if whoever has the key to this, but does not have the key to this maintainer, cannot change this OTNUM object. I see a lot of what's called cognothering going on there too. You have to.
I think this is something that we will take offline and leave written on the website.
Okay, fair enough. But is everybody happy with what I've said here about maintain lower in an OTNUM object, controlling the creation of an object with a hierarchical name? Okay, it's a hierarchical name. And I look forward to that conversation. If you have an initnum object and maintain lower, well, I'm just putting this in for the sake of completeness. If we're trying to create this more specific IP address range object, okay, then you have to satisfy the key in this maintainer. Okay? If this maintain lower is not present here, then as far as I know, this address space is not protected.
That is true.
Okay?
And it is a problem.
Okay. So this initnum objects, IP address ranges, are not part of RPS security. Okay? So if you see this here in an initnum object, however, more importantly, if you don't see this here, it means the address space underneath is not protected. Anybody can create an object underneath. Okay? I should say these objects, of course, are edited for clarity. So I hope that's the exception that proves the rule. If you have a route object can maintain lower, what I have here is I have this route object. I want to create a more specific one, then I look in this maintain lower here. Okay? I'm going to say a bit more about route objects. But maintain lower, if I have the key to this maintainer, I can create this route object. Okay? I should say the route object, this /22, can only be created by the maintain lower of the /21 object. If the route object 193.0.0.0/21 has no maintain lower, then the maintainer in maintain by is used. Okay? So if I want to create this object, I first look at this maintain lower. If this maintain lower is not present, I look at this. But this is a very special case where I'm trying to create a more specific route object. Okay? So I'm protecting my route space. I should also say, and here's the maintained routes. The what? The maintained routes or maintained by of AS333 object is also checked. What am I talking about there? You see this origin AS333. Somebody wants to create a route object underneath this route space and with its origin. There are several authentication checks that must be passed. One is due to a less specific route object, and the other is from the autumn object. And the check with the autumn object is either this attribute MNT routes or MNT by. Yeah? The whole idea is you can trust the data in the Internet Routing Registry because you know there are many hoops, hurdles, whatever, through which people must jump in order to be able to create objects. Okay, the MNT routes attribute. It's used in autumn, initnum route objects. It points to a maintainer object. It does not allow changes to the object where it appears. That's also true of MNT lower. If you have an MNT lower attribute in an object, if you have the key to the MNT lower attribute, it doesn't mean you can change that object in which it appears. MNT routes attribute controls creation of route objects. Its syntax is a maintainer name followed by a list of address prefix ranges or ANY. The default is ANY, all more specific routes. Okay? All more specific routes. What we're trying to say in this is, if you have address space that's registered in the database, if you have an autonomous system object, nobody can just come along and create a more specific route object claiming to originate from your autonomous system number and being part of your address space. That's the whole idea of this. This is where the fun begins. Creating a route object. I've actually discussed this in two different ways here. So, to create a route object, in the autumn object, the origin attribute of the route object points back to the autumn object. You have a maintained routes attribute, and if this is not present, use the MNT by attribute in the autumn object. I'll go through this process a second time as well. The route object. So you're trying to create a new route object, and you have your address prefix range, and you say origin somebody's autumn object. The first thing that they check is, does this person have the authority to create a route object originated by this autonomous system? That's checked by looking at this MNT routes attribute. If it's not present, looking at MNT by. Next, you're trying to create this route object. You search for an exact or less specific matching route object. And you will check MNT routes, MNT lower, and MNT by. So when you're searching, you first search for an exact match route object. If you find it, you check for maintain routes attribute in the exact match route object. If it's not present, you check the MNT by attribute. If there is no exact match route object, you search for a less specific route object. Okay? And then you use MNT routes, MNT lower, or MNT by, in that order. If MNT routes is not present, look for MNT lower. That's not present, look for MNT by. But notice, MNT lower is only checked when you're looking at a less specific route object. If you find an exact match route object, you look for MNT routes. If it's not present, MNT by. If you can't find the exact match route object, you search for a less specific route object, and then you might check for MNT lower. As I say, I've actually done this a second time in a few slides. Now, if there is no less specific route object, you've checked for an exact match route, it's not there. You've checked for a less specific route object, it's not there. What do? You search for an exact match initnum. If you find it, you check for MNT routes attribute. It's not there, check for MNT by. If there's no exact match initnum, you search for a less specific initnum, and then check for MNT routes. If it's not present, MNT lower. If it's not present, MNT by. Okay? So the thing is, when you find exact matches, you look for either the M&T routes attribute or M&T by. If you don't find exact matches, you look for a less specific object, check M&T routes, M&T lower, and M&T by. Now, I have take 2. I've done this a second time, and then I have some examples. Creating a route object. A route object has attribute route followed by an address prefix range. It has then attribute origin followed by an AS number. The first thing you do is check the authnom object. If you find the authnom object, check for M&T routes. If M&T routes is not there, check for M&T by. If either authentication fails, reject creation of a route object. So in other words, nobody could create a route object saying origin your AS number. Supposing this checks out. Yep, referral by. This is the top level root maintainer object. Off override. This is an attribute of a maintainer object. It's the date after which a maintainer can be modified. Only the maintainer in referral by can do this. Only the maintainer in referral by can modify the maintainer. And the auth attribute is only added if the maintainer is active for 60 days, and the value is a date. It must be greater than 60 days from the current date. Now, as I say, I haven't seen that implemented. All that we're saying is that this is for the case when you have objects that are broken, the maintainer is not responding, and something has to be done. But I haven't seen this implemented yet. Now what I do see is it's about a minute or two before 5 o'clock, and some people might have dinner appointments or other appointments to make. What I propose to do, I have a few slides. I thought I would take a 5-minute break. If anybody wishes to come back after that, I will finish the slides and talk about some advanced features, and then we're done. I imagine it will take about 10 or 15 minutes. So if you want to take a quick 5 minutes and come back, that's fine. If you want to take a quick 5 minutes and not come back, that's fine too. But otherwise, I wish you every success in using this, and I wish to thank Cengiz for permission to use some of the slides, and some people in Right NCC for some discussions, and my colleagues in Ericsson for covering for me while I was writing this stuff. Okay, and also the technical support at the back of the room. Thanks very much indeed. So I'll be back in about 5 minutes for the rest of this. I better just get the door there before... Thank you very much. Now, one of the questions people ask is, why should we go to all this trouble? There's all this new syntax, all this new semantics, we've got to learn about all this stuff. What's the payoff, apart from some of the other things that we mentioned at the beginning? And I'm going to mention this in advanced features. In advanced features, I'm just going to briefly touch upon aggregation, static routes, structured policy, but also this RA toolset or RT-config. Now you can describe aggregation in the route object, okay? And the AS here in the origin specifies the AS doing the aggregation. And this components attribute here specifies the routes used to generate the path attributes of the aggregate. And the inject attributes specify which routers do the aggregation and when they do it. Okay? And I've left out auxiliary attributes for clarity. So that's aggregation. Static routes. What we're saying here is router 7.7.1 injects this route 128.7.1 .0.0/16. And the two next hop routers are this one, 7.7.7.2 and 7.7 and 7.3. And the router has a cost of 10 over this router and 20 over this router. So that's static routes. You can also have structured policy. For example, an autonomous system AS1 prefers routes with no community, community 1:20 or community 1:10. And AS1 only accepts AS2 routes from AS2, and AS3 and AS4 routes from AS3. And the routes of AS5 customers are only accepted from AS5. So we have a structured policy. This is the autonom object for AS1. Import from AS-any, in other words, from any AS in the routing registry, except any and not RS Martians. However, we refine, and here we're talking about routes with these communities 110 and 120, and no community at all. And I'm afraid I had to go over 2 slides for this. Here is refined again from AS2 except AS2, from AS3 except AS3 or AS4, and from AS5 except AS5, AS:AS- customers. So just to quickly look at this again, this is the structured policy for AS1, prefers routes with no community, next prefers community 1:20, next community 1:10, but it only accepts AS2 routes from AS2, AS3 and AS4 routes from AS3, and the routes of AS5 customers are only accepted from AS5. And this is what the object looks like. Import, refine, and then refine again. Okay? So you can have structured policy. If you want to see an interesting AS object, there is an AS number 2764. It's maintained by Mark Pryor, and that is a very big object. It contains quite a lot of structured policy. I think Mark Pryor has given some tutorials about this as well, but it's a good example of structured policy. RA toolset and RT config. Okay? The RA toolset, the URL is at isi.edu. It's a set of routing policy analysis tools, and the IRRD and WriteDB version 3 support the query types needed for this toolset. The RA toolset has now been maintained by the RIPE NCC, and they rebranded it the Internet Routing Registry toolset. But I think they're going to do more than just rebrand it. They're actually extending the functionality. The current version is 4.7.2. That was released, I think, in April of this year. There's more information available at this URL, and there is a mailing list, irrtoolset@ripe.net. One tool in this tool set is a tool that generates vendor-specific router configurations. It uses the policy data stored in the Internet Routing Registry, and it supports several vendor formats. So, how do you use RT-config? Well, you register your policy in the Internet Routing Registry. You then create an RT-config source file. What does that mean? You basically take a copy of your router configuration file and you replace vendor-specific policy configuration commands with RT-config commands. You run RT-config. RT-config program looks at the source file, the file you've created, looks at the Internet Routing Registry, and basically you would run it like this: RT-config template config file. The commands beginning in this template with this @RT-config are instructions that tell the program, go away and do something. I'll give you an example in a moment. So suppose we wanted to generate import filters. Now this is a test object AS100. I created it in the test database, and it's IRR toolset training object. An import from AS200 2.2.2.1 at 1.1.1, accept AS200, export to AS200, announce AS100. Okay? Now this autonom object is describing the system, autonomous system AS1. It's a simple routing policy. It's only announcing to AS200 those routes originated by AS100, and it's only accepting from AS200 those routes originated by AS200. This is AS200's autonom object, very similar to before. And here are the route objects. Here is a route 130.100.100.0/24 with origin AS100, 130.100.200.0/24 with origin AS200. As I say, I created all these in the test database. And these route objects describe which AS's autonomous systems originate these routes. So this route is originated by this AS autonomous system, this route is originated by this AS. So, I run the command. This is my prompt, bash 2.0.3. This is where I get to be route, user root. RT-config space -h, I point to a whois server using this -h flag, this host flag. I point to a port number, 43. I specify the protocol as being write. I specify the source, in this case, as being test. This is actually a test database run by write. So I invoke RT-config and I get this prompt, RT-config greater than sign. Here is the command @ sign RT-config. It means everything after this is going to be processed. And I have import command AS100 1.1.1.1 AS200 2.2.2, and it generates something that looks like this. I have telescoped a lot for brevity, but access list 100, access list 100 permit this, access list 100 deny this. I think this is Cisco format, but you can choose other formats, do not gate D, so on. Okay? So the thing is, if you look carefully, you'll see this is generating an import filter for AS100. AS200 or AS100 is importing this route from AS200. So it generates this access list here. This is the rest of the output. It generates a route map, my map 200, matches IP address 100, and router BGP 100. There is the neighbor, there is the route map in. So you generated an import filter using data in the Internet Routing Registry. What we're saying is that RT-config generates import filters. RT-config generates import filters where router 1.1.1 in AS100 is importing routes from 2.2.2.1 in AS200. And RT-config generates the filters by looking up the autonom object for AS100 in the specified source, here test, in the specified database, here, this is the whois server. And it looks at the import attribute of the AS100 autonom object that contains AS200 and these routers. In other words, it's looking at this line, okay? It's looking at this line to generate these access lists and this route map. Now, RT-config can also generate export filters, but I haven't shown them. Okay? What's the advantage of using route sets? here I have a route set object, rs-as10,000. This object describes routes, not route sets. Here's some routes, members by ref. And if I run rtconfig again I say the command access list filter rs-1000. This only means continuing on to another line. I couldn't fit it all on the slide like the way I had. And now I'm generating access lists based on this route set. Yeah? So these are the members of my route set. And here I've generated an access list based on that using rtconfig. Any questions? Sorry, I beg your pardon.
Take the actual access list number for you.
I think you can configure that yourself. It might be a switch within rtconfig. Okay? But if you generate another access list, this will be incremented, either by 1 or by 5 or by 10. I think that's a switch in rtconfig. But that I see as an implementation detail, but it's a good question. Now, any other questions? Static routes. Here I have AS number, Autonom object AS10,000. It's a test object I created in a test database. Import protocol static into BGP4 from AS10,000, action ASPath.prepend AS1, except these routes. This route set rs-as10,000. I showed you that route set, and this is the important word here, protocol static or protocol static into BGP4. Protocol static into BGP4 injects static routes into the BGP4 routing protocol. Here is the action. I set or modify the value of a route attribute terminated by a colon, semicolon. The routing, okay. So here we have the static routes, rtconfig static to BGP AS10,000, 192.16.151.10, and here I generate an access list, okay, and a route map. What we're saying is that this router is injecting routes into BGP4, and what you do is rtconfig looks at this part of the Autonom object for AS10,000. This is so rtconfig looks at this part, the import attribute with protocol static into BGP4 from AS10,000, looks in this part of the Autonom object for AS10,000. Here's the rest of it. Sorry. This is the first part of the output, generates an access list, and then it generates a route map, and at this command to redistribute the static routes. As I say, these values I think are set by a switch within rtconfig, by how much they increment. There are other tools. Any questions on static routes? Okay, there are other tools within our tool set. The Route Object Editor, ROE, the Autonomous System Object Editor, AOE, PR Traceroute, PR Path, PVAL, Cider Advisor, RPSL, check. PR Traceroute is policy and route information. PR Path is a list of paths between AS and the destination. PVAL is a low-level policy routing tool. You could write router configuration tools based on that. Cider Advisor suggests Cider aggregates that do not violate policy constraints, and RPSL is a syntax checker. The Route Object Editor, it lists routes registered by a provider, shows discrepancies, shows holes, and can be used to correct these discrepancies. And it has a front end, which is a GUI that allows you to correct these discrepancies and update the Internet Routing Registry. Okay, so it has a GUI like this that allows you to easily make changes. The Autonomous System Object Editor This has recently been changed to make it RPSL compliant. I think this example is not RPSL compliant, but it has been changed, and it is now RPSL compliant. And some useful links. RPSL, you find it at isi.edu. You also find it on the right page, and also on the RADB, www.radb.net, as well as at www.irr.net. The RA toolset, now renamed the IRR toolset, you'll find it at the ISI website, or at right, we're now maintaining IRR toolset. Roll credits, start music. Audience gets up and starts walking out. So some acknowledgements. First, Genghis Alatinoglu, I'm not sure if pronouncing his name correctly, of Packet Design Incorporated. He provided the slides from which many of these slides are derived. I have written my own slides as well as this. If there are errors, talk to me. Also some discussions with some RIPE NCC people. Joao Luis Silva Damas, Andrei Obachevsky, Engin Kundas, Shane Kerr, Vesna Malovic. I spoke to them, had some ideas in putting this together. The engineering group in RIPE NCC, had some discussions with them. Also, I'd like to thank the technical staff for getting this all ready for me this afternoon and recording my deathless prose for posterity. Lastly, my colleagues in the Ericsson Global Expertise Centre in Dublin, particularly Network Consulting Managed Services Department, Service Network and IP Engineering Group, who covered for me and basically understood what I was doing.